let's talk about meshing. It's a key step for any engineer who's doing simulation. See, computers can't analyze a perfect shape directly. They have to break it down into something simpler. And that process is called meshing. It turns one huge problem into lots of small, solvable ones. Every mesh has just two basic parts, nodes, which are just points, and elements, which are the shapes they form. For 3D parts, you'll mostly see these two, tetrahedra and hexahedra, bricks. Tet elements are super easy to generate automatically. Hex elements are way more accurate but tougher to create. Which brings us to the big question every engineer struggles with. Exactly how fine should this mesh be? A coarse mesh is really fast to solve. A fine one captures detail, but it's computationally expensive. So you see, it's always a trade-off. Finer meshes are more accurate, but they seriously increase calculation time. In fact, making the entire mesh super fine is just inefficient. It'll completely drain your computer's resources. The smart move isn't making it fine everywhere, but only in the specific areas that actually matter. This technique is called mesh control. We just apply a fine mesh to critical zones, like this high-stress fillet. Now, this is crucial. You have to know the difference between a real stress concentration and a singularity. If stress just keeps climbing as you refine, you've got a singularity. The fix is to add a fillet. So, you've run the analysis. How can you be sure the results you're looking at are actually right? You do something called a mesh convergence study. You keep refining the mesh until the results stop changing. Once that change is minimal, say under 5%, you know your answer is solid and doesn't depend on the mesh anymore. So just remember, start coarse, refine smart, fix singularities with fillets, and always check for convergence. And a final thought, getting an answer is easy, but your mesh is what proves you can actually trust it.